Hi, this is an explanation for problem 56 in chapter 11. This problem has 5 different parts. It says the winning time for the 2005 annual race up 86 floors of the Empire State Building was 10 minutes and 49 seconds. The winner's mass was 60 kilograms. So part A asks us, if each floor was 3.7 meters high, what was the winner's change in gravitational potential energy? And so how we calculate gravitational potential energy, we can use mass times gravity constant times height. So to calculate the height, we're going to use the 3.7 meters, and we went up 86 stories, so that gives us a total of 318.2 meters. Now we're given the man's mass in the initial part of the problem. Oh, it's actually 68 kilograms. Sorry, I wrote that wrong. So again, gravitational potential energy is analogous to mass times gravity times height. So we can plug in now our 3 values, 68 kilograms times 9.8, the gravity constant, times 318.2 meters. We'll have a total of 187 kilojoules. Part B then asks us, if the efficiency in climbing stairs is 25%, what total energy did the winner expend during the race? Well, if he expended 187 kilojoules was our gravity potential energy, then our change of efficiency being 25%, we would just use 187 kilojoules divided by 0.25, which would then give us 748 total kilojoules expended. Part C asks, how many food calories did the winner burn in the race? Well, we know that there are 4.2 kilojoules per calorie, and so if we expended 748 kilojoules in the race, then we simply divide by our calculator to calories, and so it would be 748 kilojoules divided by 4.2 kilojoules per calorie, and that will give us a total of 178 calories burned. Part D then asks, of those calories that were burned, how many were converted into thermal energy? All right, so we have 178 calories burned, and we know we were only 25% efficient. So if 25% of the calories that were being burned were being used for energy, that must mean that 75% of the calories burned were then just going into thermal energy. So we can just multiply 178 by 0.75, and that will tell us that 134 calories were actually just converted into thermal energy. And finally, part E then asks us, what was the winner's metabolic power in watts during the race up the stairs? So for watts, power is calculated by the amount of energy we used divided by the time. And so our time was 10 minutes and 49 seconds. I converted this into 649 seconds. We had our power that we generated, or energy that we generated in kilojoules, but I converted that to joules for this calculation. So we have 748,000 joules divided by 649 seconds, which will give us a total of 1150 watts.